You know when you look at the screen on a new smartphone or a high-end TV and the colors are just so vibrant and the blacks are so perfectly black? Have you ever wondered how it actually works? Well, the science behind it is absolutely fascinating. And believe it or not, the best way to get it isn't with a bunch of boring diagrams, but with a fairy tale. So let's dive in. Okay, so for a few minutes, I want you to forget everything you might know about circuits and electricity. To really understand how an OLED screen makes light, we're going to tell a story. And our story today is called The Dance Party at the Squishy Jelly Castle. And yep, it's every bit as fun as it sounds. All right, so imagine this. Every single pixel on an OLED screen, and there are millions of them, is its own tiny magical castle. But this castle isn't made of stone or bricks. Nope. It's made of a special, squishy, carbon-based jelly. And inside this castle, there's a huge party going on. Now, this jelly is what makes the whole thing possible. Because it's an organic, carbon-based material, it can be made incredibly thin. We're talking paper thin. It can be transparent. It can even be flexible. It literally bends like magic. This is exactly why you see those cool rollable or even see-through OLED screens. It's all because of the jelly. Now, every good castle, and especially every good party, has to have some rules. And our Jelly Castle has one single, super important rule that makes everything happen. It's the light rule, and it's the secret to the entire show. The rule is simple. You want to make light? You have to find a partner and dance. That's it. There are no giant floodlights, no big backlight shining from behind the stage. The light comes from the party guests themselves. And this, right here, is the key idea behind OLEDs. They are self-emissive. Each tiny pixel makes its very own light. So, how exactly does this dance party start to glow? Well, it all happens in 4 pretty simple steps. Let's break it down and see how all this magic is made, one step at a time. First step, step 1, injection. I mean, you can't have a party without guests, right? So this is the moment you turn the power on. The castle doors swing open, and all the guests start to arrive for the big dance. And check out who's showing up. From the left door, the cathode, we've got these super energetic Electron Boys just buzzing with energy. And coming in from the right door, the anode, are the elegant hole girls gliding in. So meet our 2 main characters, electrons and holes. Okay, our guests are in the castle. But hey, the party isn't happening by the doors, it's on the dance floor in the middle. And that brings us to step 2, transport. Everybody's got to move to the center. Luckily, this castle is designed for a party. The Electron Boys hop on what we'll call the electron transport layer escalator. Meanwhile, the hole girls take the whole transport layer moving walkway. They're both headed for the exact same place, the central meeting plaza. In scientific terms, that's the emissive layer. And here we go. This is the moment we've all been waiting for. After traveling all the way from opposite ends of the castle, our party guests finally get to meet each other. And this is where the magic really starts to fire up. Right there, in the middle of the dance floor, an Electron Boy finds a hole girl partner. They pair up, and when they do, they create something totally new and exciting. This special, high-energy dancing couple has a name. It's called an exciton. And just so you know, I'm not making that word up. Exciton is a real scientific term. It describes this temporary, super excited state that happens when an electron and a hole bind together. The easiest way to think of it is just as a little packet of potential light, just waiting to burst out. We've made it to the grand finale. The guests have arrived, they've traveled to the center, they've found a partner. There's only one thing left to do. It's time for step 4, emission. It's time to dance and glow. So as our new exciton couple dances, all that initial excitement and high energy starts to calm down, and they settle into a more stable, relaxed state. And as they chill out, they have to release all that extra energy. And how do they do it? As a beautiful little flash of light, a photon. They literally glow. And depending on which room or which type of jelly they're dancing in, they can glow red or green or blue. Okay, the dance party was a massive success. The whole Jelly Castle is glowing beautifully. But what does this fairy tale really mean in the real world? Well, let's compare our magical castle to its next-door neighbor, what we'll call the old-fashioned LCD theater. And this image says it all. On the left, the LCD theater needs this huge, powerful backlight that's just always on, shining through everything. But our Jelly Castle on the right, it has thousands of tiny couples making their own light, precisely where it's needed and exactly when it's needed. No backlight at all. So let's just spell it out. The Jelly Castle, our OLED, is self-emissive. That's why it can be paper thin and even rollable. The LCD theater needs that big backlight, which makes it thicker and totally rigid. But here's the big one. Because our little dancing couples can just stop dancing to create darkness, OLEDs get you perfect absolute black. LCDs, on the other hand, always have a little bit of that backlight bleeding through, so you get more of a dark gray.
So here it is, our official fairy tale to science decoder ring. The Jelly Castle is the organic compound. The Electron Boy and Hole Girl are, you guessed it, the electron and the hole. The meeting plaza is the emitting layer, or EML. Our dancing couple is the exciton. And that beautiful glowing, that's self-emission. See? It all lines up perfectly.
Okay, so we've covered the how. But what about the why? Why does this whole story about a magical dance party inside a jelly castle actually matter for the phones and TVs we use every single day? Probably the best way to think about the difference is with this one last analogy. A traditional LED is kind of like lightning striking inside hard inorganic rocks. It's powerful, it's sharp. But an OLED is much more gentle. It's more like thousands of fireflies dancing inside a soft jelly. It's this warm, organic, self-made glow. So if you remember anything from all this, let it be these three things. 1, OLEDs create their own light. They are self-emissive. 2, because any pixel can turn completely off, you get perfect, true black levels, an amazing contrast. And 3, this tech is what lets our screens get unbelievably thin, flexible, and even transparent, which is just opening up a whole new world for what's possible. And that really brings us to the final thought here. This amazing technology we just talked about, this dance of fireflies and jelly, is already changing everything we thought we knew about displays. So it just leaves you with one question, right? If our screens can be as thin as a piece of paper and as bright as fireflies, what on earth are we going to create next?